All right, let's talk about a choice that every single developer has to grapple with. How do you process your data? Now, if you get this right, your application is snappy, it's reliable. But if you get it wrong, well, you're staring down the barrel of bottlenecks, crashes, and some very unhappy users. So let's dive into the two main strategies. It really all boils down to this one question. What's your top priority? Do you need a system that has to react right now, where every single millisecond is critical? Or are you trying to tame a massive mountain of data that just needs to get processed, reliably, even if it takes a little while? That's the core trade-off we're looking at, speed versus scale. And this really lays out the two extremes perfectly, doesn't it? On one side, you have these super urgent real-time tasks. Think about a financial trading platform. A delay of even a split second could literally cost millions. And then on the other side, you have these huge scheduled jobs, like generating every single bank statement for a month or updating an entire e-commerce inventory overnight. These are just fundamentally different kinds of problems, and they need fundamentally different solutions. So how do we solve these problems? Well, we rely on two primary paradigms or ways of thinking, asynchronous and batch processing. Let's break down exactly what each one is and, what really makes it tick. So first up, we have asynchronous. The keywords to remember here are continuously and real time. Async is all about being responsive. It grabs data the second it shows up and starts working on it without waiting in some long line. It's kind of like having a whole team of receptionists ready to answer calls as they come in instead of just one person taking messages to deal with later. The real power of async comes down to a few key things. It's immediate, it's super efficient with your resources, and it scales like a dream as more data flows in. But, and this is a big but, there's a trade-off. When you have so many things happening all at once, handling errors can get really, really complicated. It's like a high-performance race car, incredibly fast, but it needs a very skilled mechanic to keep it running right. Okay, so that's async. Now, let's flip the script and talk about its counterpart, batch processing. Instead of dealing with data the moment it arrives, batch processing is all about patience. It collects data over a set period, maybe an hour or a day or even a month, gathers it all up into one giant group, or batch, and then processes it all in one massive go. And this is where batch processing is an absolute beast. It is built for enormous volumes of data. We're talking terabytes, even petabytes. It's designed for massive scale, and, maybe most importantly, for fault tolerance. The whole system is engineered to be tough and reliable, so if a huge job fails, it can be restarted without losing data. It's not about being the fastest off the line. It's about unstoppable, reliable throughput. So you have these two really powerful options in your toolkit. How in the world do you choose? Well, it all comes down to understanding the trade-offs and matching the right strategy to your specific problem. This chart really puts the whole decision into perspective. You can see, side by side, async is the clear winner on response time, right? That low latency is absolutely essential for real-time apps. But then you look down at error handling and complexity, and suddenly batch looks a lot more attractive. It's simpler and way more robust. So you're basically trading that instant speed for operational simplicity and rock-solid reliability at a massive scale. Let's make this super concrete. You choose asynchronous processing when latency is the enemy, when every millisecond counts. If your app's whole reason for being depends on instant feedback, like executing a stock trade the moment you click buy or rerouting traffic around an accident as it happens, then async is pretty much your only choice. But you go with batch processing when the sheer volume of data and the need for absolute reliability are king. For those jobs that are just too big to handle in real time and must be completed correctly, like end-of-day financial reporting or generating those millions of bank statements, batch is the undisputed champion. Okay, so we get the theory, but what does this actually look like in the real world? When you have a truly massive, mission-critical batch job, how do you manage it without losing your mind?
Look, when you start dealing with seriously large-scale batch processing, trying to build all the plumbing from scratch is just a recipe for disaster. You need a framework that was built for this, one that already understands the challenges of volume, reliability, and scaling. So let's take a look at a really popular example from the Java world, Spring Batch, to see how these concepts are actually put into practice.
One of the absolute killer features in a mature batch framework is a scaling technique called partitioning. The idea behind it is actually pretty simple, but it is so powerful. Instead of trying to run one gigantic job on one thread, you intelligently split the work up into smaller, independent chunks that can all be processed at the same time. So here's how it works. You have a central manager step that gets the job. Then, a component called a partitioner acts like a great project manager, breaking that huge workload into smaller assignments. It then hands off these little assignments to multiple worker steps that can all run in parallel. It's the classic divide and conquer strategy, but it's built right into the framework for you. Okay, that's great for speed, but what happens when things go wrong? And trust me, in a job that runs for hours and processes millions of records, things will go wrong. This is where the true power of a dedicated batch framework really becomes obvious. I want you to just imagine this nightmare scenario for a second. You've got a job processing 1 million records. It runs for 3 hours, it's chugging along, it gets to record number 800,000, and then the system crashes. Do you really have to start all over again from record 1? With a framework like Spring Batch, the answer is a resounding no way. And the magic behind this is what's called its metadata schema. The best way to think about this is as the job's long-term memory. It's a set of database tables that meticulously tracks everything the job does. Think of these tables as a super detailed flight recorder for your job. They track every single run, the status of each attempt, whether it started, completed, or failed, and exactly how many items were processed. So when that job dies at record 800,000, the framework already knows. You can just restart it, and it intelligently picks up right where it left off. For reliability at scale, this is an absolute game changer. So a full-blown batch framework is incredibly powerful. But does that mean you should use it for everything? Not at all. The final piece of this puzzle is knowing when to bring out the heavy artillery and when a much simpler approach is actually the better choice. This quote from the legendary Brian Goads hits on a really key idea. Sometimes all that heavyweight machinery is just plain overkill. For simpler background tasks, a well-tuned asynchronous system can be way more efficient. There are even formulas like this one to scientifically figure out things like the optimal number of threads, proving that a lightweight approach can be just as carefully engineered. And this brings us to a very practical rule of thumb. Use a heavy-duty framework like Spring Batch for your big, complex, mission-critical jobs, the ones that need those robust features like restartability and partitioning. But for simpler, on-demand background tasks, like, say, sending a confirmation email after a user signs up, a simple tool like Spring's @async annotation is often the perfect low-effort solution. So at the end of the day, the most important takeaway is this. Don't use a sledgehammer to crack a nut. You have to first really, truly understand the scale, the complexity, and the reliability that your task demands. Only then should you pick your tool, making sure its power and complexity are a perfect match for the problem you're trying to solve. And that leaves us with a really fascinating question to think about for the future. As the amount of data in the world continues to explode, and at the same time, users demand faster and faster responses, are these two worlds, async and batch, going to start merging? We might start seeing more hybrid systems that try to blend that real-time responsiveness with massive processing power. It's a huge challenge, and it's going to be exciting to see how the next generation of data engineering solves it. Thanks for joining this explainer.